Hello everyone and welcome to yet another recreation programming session with Mr. Zozin and his disco t-shirt. We've been working with Raylib for quite some time, right? And the interesting thing about Raylib is that it has two notions for sound, right? So let's actually take a look at that. So if I go to the raylib.h, so it has a notion of sound, right? So there you go, here is the sound. And it has a notion of music. So what's the point of separate, like, I mean, they already... They already put it in the documentation, but the question is, like, what's the point of separation of these two things? And the point is that music is an audio stream anything longer than 10 seconds, right? So music is basically a long one. Sound is a short, music or sound. So, and essentially the way it works, I think, is that a sound is loaded entirely into the memory, and music is sort of like a slowly streamed as it plays, right? Because it can be pretty big. You maybe on some platforms you don't want to actually keep the entirety of the music in the memory, right? Or at least like loading up that music is not going to take that long if you're just streaming it from the hard drive, right? So but since the sound effects are usually very small, like loading them up into the memory like doesn't really take that much time. But to be fair, I would like to confirm that. So if we take a look at the function, something like a load sound, not loud sound but load sound, right, so that's the thing that basically loads it from the hard drive. And let's actually find the implementation of this function. Right, so I'm gonna actually do something like sound, loud sound. Okay, so that is probably the implementation. And the first thing it does, it loads the wave. So actually there is a third, representation of sounds. It's the wave, right? So we can take a look at the wave. And wave is literally the sound samples stored in the memory, right? So the sound in the computer represented as samples, right? So the wave is just like a sequence of integers, and wave in here, structure wave, is just like stores that. So a usual small sound just loads the entirety of this thing in the memory, and then just like, parses that wave and gives you the sound object that you can then play and stuff like that. If we take a look at the load music, it actually does something slightly more interesting. I think that's the function that loads the music stream, right? So what it does, depending on the format, right? So the first thing it does, it tries to determine the format, right? So as you can see, it takes the file name and then looks at the extension of that file name, right? And if the extension is WAV, it does one thing. If the extension is OGG, it does another thing. If the extension is MP3, it does the third thing, and so on and so forth. You get the gist, right? So you get the gist. So let's take a look at the wave, right? So what it does, it allocates a little bit of memory for like a context, some sort of a context, which is called Dr. Wave. Right, and then it uses the Dr. Wave init file to create that context and stuff like that. So essentially the idea is, depending on the extension, it uses different sound library to process different formats. Right, so it's basically a little bit of the polymorphism in C. Even though this is a pure C library, it still does a little bit of a polymorphism depending on the extension, right? So you can do whatever you want in C, right? So polymorphism is just a fancy name for dispatching, right? For dynamic dispatching at runtime. That's what literally it is. Right, so in the case of the wave, it uses the library called Dr. Wave, right? So we can take a look at that. I think it's located in external, right? So Dr. Wave, right? So it's a wave library. It's an open source, like a header only library that you can use if you want to, right? So you don't really have to use Raylib if you want to process some wave files. You can just like use this library. In fact, this is something that I like really recommend you to do. Go into the source code of Raylib, right? And not only try to read it, but look into the src external folder. Look at the src external folder. This folder contains all of the like header-only libraries that Raylib uses, and there's a lot of them, right? If you want to discover some cool header-only libraries, check out this folder, SRC, external, and Raylib. I really fucking recommend you, right? So because I discovered a lot of cool things in here. So apparently there are header-only libraries for processing these formats, like FLAC, MP3, WAV, and they are just one file per format, right? So there's things for like just playing sounds on any platforms called mini audio. We already looked into that. So there's a lot of cool things in here, like a fair amount of STB libraries as well. Not all of them. There's a lot more STB libraries, but this is the main ones that Raylib is using. So and Raylib is basically like gluing them together for you in a nice like a unified interface for a game library, right? So Raylib is valuable not only as a library that you can just plug in and start making games, it is valuable as a learning resource. Just reading the source code of Raylib is extremely valuable. You will learn a lot of interesting shit, like trust me. It's fucking cool. That's why I really like this library, right? So because just like open it up, it's really easy to read. As you can see, we're already reading the source code of Raylib and you will learn a lot, right? So, and there's a bunch of examples on how to use this libraries anyway. So let me take a look at that. Right, so it uses this entire thing, and what it does, it doesn't really load the entirety of the file, it just initializes the context, right? So initializes the context. And right, so then it creates an audio stream object, and that's it, right? So it doesn't really load the entirety of the file. It just prepares the context which is going to decode you know, this file, and that's it. And if you're using music, right, if you ever worked with Raylib and you are playing some sort of a music, you know that on each frame periodically you have to call a function called update music stream for the music you're currently playing, right? So this is the source code, right, that basically uses that functionality. Right, so you periodically update this entire thing. So if you take a look at this function, update music stream, right, so what does it do? What does it actually do? So it tries to figure out like how much stuff it needs to read, right, how much stuff it needs to read. And if I'm not mistaken, right, if I'm not mistaken, and then it then dispatches on the type of the context, whether it's a WAV file or something else, it just pulls a little bit of the frames, from that specific context, right? As you can see, in the case of a WAV, it just uses Dr. Wave thingy to pull those things. In case of OGG, it uses STB Vorbis to pull a little bit of the stuff, and so on and so forth. Right, so that's basically the difference between these two things. We are using this functionality in Visualizer, the music visualizer that we've been working on for quite some time already, right? So I'm going to give the link to this entire thing here. I'm going to put it in the chat, and for people who's watching it on YouTube, it's going to be in the description, right? So, and essentially so the way this entire thing works, let me actually start the visualizer to demonstrate how exactly it works. And maybe another thing I want to do, I want to open this folder that we have in here so I can drag and drop stuff. So the visualizer actually only accepts files that are drag and dropped, unfortunately, as of right now. So let's actually see. Maybe I'm gonna take some short music. I don't really know, maybe this one. Right, so it looks like this, right? So you drag and drop the music and it starts playing the music, and then you may want to actually render it into some sort of an animation, right? So that's basically what it does. So it's going to render that specific animation into the file. The interesting thing here is that when we're playing the music, we're loading it as a music, but then as we render the music, we're forced to actually load it as a sound. Not really as a sound, but actually as a wave. So let me actually go to plug.c. All right. So when I press, I think it's something like KR, right? So key render. So to render, I think, okay, so here we have a function start rendering the track. Right. So yeah, I already have a track that is loaded as you know, as a music, and then before I render it, I load it as a wave, And the reason why I do that is because I need to get the samples, the actual samples of the wave, so I can render the animation in offline without actually playing it. You know what I'm talking about? So like I need to have both the stream because I'm playing it, right, as I'm visualizing it, and I also need to have the samples to just render it into the final video. So it's all cool and stuff, but it actually makes it difficult to render things that are big, right? So for example, I have a big file in here, Pilot Red Sun, the entirety of the album in here, right? If I try to visualize this entire thing, and if I drag and drop this entire thing, it's actually super fast. It loaded instantaneously, right? It loaded instantaneously, even though I think it's around 20 minutes. I'm pretty sure it is around 20 minutes. We can actually take a look at how big it is. So if I do ffprop, right, it's supposed to tell me how big it is. Let's set another one, whatever. It's actually 45 minutes. Huh, right, it is 45 minutes, even though I dragged and dropped it in here and it loaded like instantaneously. This is because it uses streaming. Right, so it doesn't load this entire thing into the memory, right? It just like opens it up, and as you need to play it, it like lazily loads it from the hard drive. But if I try to actually start rendering it, it actually hangs. It actually hangs because it's trying to load all of these 45 minutes into the memory, and so just like it does not respond. Precisely because of that. Like precisely because of that. So it's oof, that literally oof, like I know. So, and the answer to that would be probably, well, just use the stream, right? So just when you are rendering, just use the same trick as when you're playing. But the problem is the music stream is a black box. Not really black box, but more like opaque box. So the only thing you can do with the music stream object in Raylib is load it from file and play it. That's it. You don't have an access to all this underlying context, whether it's a WAV file or GG file, everything that I just showed you. All of that is hidden from you. It's hidden from you. It's encapsulated. OP people, are you fucking happy? Are you fucking happy with your encapsulation polymorphism bullshit? Like actual useful functionality that would solve my problem, it's abstracted away. It is fucking abstracted away. That's a perfect emote for that. You can't see that because the boomer doesn't animate it, but it's just like a doc notel. Yeah, exactly. That's perfect. I can try to do that beat, but I mean the microphone is actually on my desk, so the sound is going to be too loud, right? So yeah, and that's basically what I want you to do on today's stream, right? So I want you to like hack Raylib and expose all of that functionality, because that's another beauty of Raylib. Not only it is easy to use, it is easy to read. You can read this entire thing. It is also relatively easy to modify, right? So it's completely open source. You don't like something about the interface of Raylib, just modify it, right? So one of the things we do in this project, by the way, we actually copied and committed the entirety of the source code of Raylib into the project, right? So this is the entirety of the source code. Like I removed some stuff at the root of the project because it's not really relevant, right? But the source code itself is just here. And every time we're building the project, not every time, well, we cache it, right? So, but when you build the project, it also builds Raylib for you, right? So if I remove the build folder and I try to rebuild this entire thing one more time, right? Like so. So the first thing it does, it builds Raylib from scratch. And Raylib is a relatively small library, so it lags a little bit, right? Because we're like doing that in multi-threading and stuff like that. And Raylib is a relatively small library, so it's not going to take that much time, right? So it's going to be relatively fast, and it's not going to build it the second time. It actually caches that, and then it's going to build the visualizer itself, right? So the Raylib is so small, you can just afford simply committing the entirety of Raylib with your project and just building it with your project, right? So doing that on each rebuild is a little bit too much, right? So, but I mean, you can always cache it. So that's pretty cool. That's pretty cool, I think. All right, so what I want to try to do, I just want to try to understand how we can basically exploit, you know, this ability of the thing to sort of like stream from the file system, if you know what I mean. Right, it's kind of interesting. External Raylib. Yeah, I was actually thinking to maybe similarly create like external folder and put Raylib in there, but it's more like an organizational thing, right? So just like a little bit of bike shading. At this point, a little bit of a bike shading. So we'll get some subs, by the way. So let me acknowledge the subs super quick before we dive into this entire stuff. Thank you so much, ZLC, for your application with the message. I'm from Hong Kong. Really appreciate you inspiring stream. You're welcome. Right. I'm really I'm really glad to hear that. So I'm really like, it's interesting, like from how many places around the world people watch me, right? So it's actually super cool, right? So we're living in a really interesting time, right? So where you can just like have a camera and microphone, right, and just like make a public talk, right, to the entirety of the world, right, to the entirety of the world. You don't have to sign up to some sort of like a fancy conferences, right? So like pay a huge fee or anything like that. You just have to pay for the internet, you have to pay for the mic, you have to pay for the webcam, and you can give a public talk. And if it's worth anything, it's gonna get trendy on social media and people will hear you, right? If you have anything of a value to say, the social media algorithm will probably pick it up and amplify it, right? So that's actually super cool. That's actually super cool. So yeah, Rorinka, thank you so much for Twitch Prime with the message Tsoding Pogin at twice. Tsoding Pogin at twice. FGLG, thank you so much for Prime subscription with the message Wahoo! Strange time for you to be streaming. Yeah, I'm really sorry. My sleeping schedule is a little bit fucked up. So yeah, maybe the next stream is gonna be at the usual time. I haven't decided yet. So people from all around the world in the chat. Yeah, that's actually super cool. It's actually super cool. Anyways, so let me actually see what we can do in here. Maybe I'm gonna start with maybe creating like a very simple project that just streams the like a big file, right? So how do we even stream big files? So the big file that we have is in OGG format, right? So it's Palette Red Sun OGG. So let me see. Our audio, so this is the name of the module, right? So it's STB Vorbis, right? So they're using STB Vorbis. Load music stream, where is that function? And if the extension is OGG, yeah, so they're just opening this entire file, right? They're getting some additional info and stuff like that. And that's about it. Honestly, maybe I could just use these functions directly. Right, so just use this library directly bypassing Raylib, right, instead of loading the entirety of the wave, right? So look at the extension and just do this kind of thing. Or maybe I can factor out this entire code that just does the polymorphism depending on the extension and have my own sort of object that allows me to stream things. That sounds interesting, actually. That sounds interesting. So, but they also have a notion of audio stream, and I'm not sure if we can easily use that. We'll see, we'll see. In any case, let's actually create something like main, maybe prob ogg.c, prob ogg.c. So I'm gonna do something like this, and maybe something like this. And I wonder what's gonna be the easiest way for me to even build this entire thing, right? So maybe I can build that in Knob. Right. But Knob is actually by itself is rather complicated thing. But I mean, I don't freaking know. I can just try to do that. So maybe in a stage 2, right? So if I take a look at the Knob, yeah. By the way, recently I created a separate folder which is called src_build, right? Because for those who doesn't know, we're using like a very interesting build system. It's a custom build system that is written entirely in C, right? So instead of like using some you know, some other language like CMake or whatever. We're using C. Right, and I recently put everything related to building the project into SRC build. Right, into SRC build, and all of that is also written in C, so it's actually kind of cool. So it also has 2 stages, right? So it bootstraps itself and stuff like that. So yeah, so I don't really know where we're gonna build in all of that. Maybe in a stage 2, right? So maybe in a stage 2, and in a stage 2, when we're just building some stuff, we're building the visualizer itself. And I suppose this is where we can build the prop thing, right? So we can always do nob cmd like so, and then we're gonna say nob cmd append cmd, so it's gonna be cc, and maybe I'm gonna also enable a bunch of like extra things in here, like so. Look at that. And so the output, I expect the output maybe to be in a build folder, build prob ogg, and the input is going to be, I suppose, just prob ogg.c, right? So, and then we just run nob cmd run synchronously, right? So we run this entire thing synchronously, right? And if it fails for whatever reason, we just exit with non-zero exit code. So that's it. So we can actually put a little bit of a code in here like that. After the experiments, we're probably going to remove it, right? So I just need some place where I can just put this entire stuff. So let me try to rebuild this entire thing. Is it going to build that thing? I think it is yeah, look at that. So it actually built this entire thing, but it takes some time to build the visualizer. So maybe to speed things up, I'm going to say don't build visualizer as of right now, right? So it's only going to build the prop ogg, right? So our build system is entirely dedicated to building prop ogg now, right? So and all of that again is purely in C, right? So you can do all of that purely in C. So let's actually put hello world in here like so. Let me see. And afterwards I can do build prop ogg, yeah, and it says hello world. Would you look at that? It says hello world. Cool. So we probably want to include the stb vorbis, vorbis.h, and I suppose, like, what's the difference between vorbis and ogg? Does anybody know? Like, why do people use these two words interchangeably? So I suppose the name of the format is vorbis and the extension is just ogg. It's kind of weird, honestly. Vorbis ogg. So what's up with that? Ogg is a container, vorbis is a codec. Oh, I see. Is a free open source software project leading, yeah. Is a free open source, well, I mean, like, that's not very useful descriptions and stuff like that. Ogg can also be Otis. Okay, so that explains it. So Ogg is just a container, right? So like MP4 or something like that, and you know, vorbis is a codec. Okay, that's pretty cool. That's pretty cool. That's pretty cool. Thank you for explaining that. I didn't know that. I genuinely didn't know that. All right. So if I try to build this entire thing, it's not going to build because we don't have an access to all of that stuff. But luckily, this particular file is actually located within the Raylib folder, right? So we can go into the Raylib. We can say type file F, right? So and then find that it doesn't. Ooh, what the fuck? Aha. It's actually C. It's not H. Why is it called C and not H? Wait, I thought it's a header. What the fuck? Find file at point. So, stb vorbis, nothing's st. Yeah, I thought it's H. Why was it renamed from? Yeah. Sus. I want to take a look at that. If I go to nothing's stb, Raysan did something weird in here, I think. So vorbis, it's okay. Why is it C though? Look at that. That is so bizarre. Why is it C? Look, all of them are H, but this one is specifically C. Was it a mistake or imposter? Yeah, exactly, imposter file. So, and yeah, maybe it's an old one of some sort. Hey, I don't freaking know. So does it have the implementation macro? Implementation doesn't even have implementation macro. That's really weird. But anyway, okay. So I suppose it's just C, right? So, and it still won't find it if I try to build this. I think it just doesn't really matter because like it doesn't have this file in the search, right? In the search path. So one of the things we have to do in stage 2 is probably add something like I, right? So in here we're going to say Raylib, Raylib, and then as far as I know we have a Raylib version in here, so we can do something like this, Raylib version. And maybe I'm gonna just leave it as it is. I'm gonna provide the src, right? So, and then I'm gonna say that I wanna include from external, right? So I wanna explicitly say that it's something external, right? So if I try to rebuild this entire thing one more time, is it going to build? It in fact built, right? But it couldn't link, couldn't find functions like sine, cosine, because they are all in a math, right? So let's actually go in here and link all of that stuff with math, like so. I think it's going to work now. That's pretty cool. That is in fact very, very cool. Okay, so let me go and see what we can do in here. So when we are so we want to call stb vorbis open file, right? So that's probably the first function that we want to call in here. So here we have a file path of some sort, and the big file that we want to work with is going to be the pilot red sun. So I'm going to go into the music and I'm going to just find this thing, right? So I'm going to say that this is what we're working with, music, pilot, red sun, boom. So, and the question is, what kind of parameters this function actually accepts, right? So let's actually find it. So what is this function? It accepts file name, okay, that makes sense. And then error, and then stb vorbis. Ooh, so it accepts a custom allocator. That is actually super cool. What? Ooh, wait, it's not even a custom allocator. It's a buffer that you can pre-allocate, so it will allocate all of that stuff into that buffer. That's pretty cool, isn't it? It's almost like an arena. Well, I mean, arena is a little bit more sophisticated notion, right? So arena is actually a bunch of such buffers that are put in linked lists, right? So they connect it with linked lists, right? So this kind of thing, it cannot extend very easily, right? So it doesn't really grow. It's a fixed area, but arena is a bunch of these like fixed areas actually. Right, so what this thing does, it just like opens a file, right? So, and what about an error? I suppose maybe it indicates an error, yeah, so returns null and sets an error to some sort of a value. This is very unusual actually. Or maybe not, maybe it's fine. So that's pretty cool. So instead of like a global error no, why libc doesn't do this kind of shit? Well, I mean, that means you'll have to actually provide this parameter for each C function, but at the same time, you have to check the output of each function anyway, so... But this one at least gets rid of the global error no variable, which is very annoying to work with. Who it's Nothings, right? Nothings developed this thing. It's so cool. I swear to God, like every time I read the code developed by Sean Barrett, I learned something new. Like I learned something new not only about C, but about programming in general, just like different ideas, right? So I don't fucking know. Like it's so cool. libc was made in the 80s when the global variables were fine, I suppose. So global variables are fine when your programs are smaller, right? So, and maybe that was the justification. Have you ever explored standard C libs? Yes, I have. I explored Musel because it's easier to explore than glibc, right? And it's actually kind of cool. I really enjoyed what I saw there. I always get lost in the macros and hundreds of files, and it feels so hard to find. Explore Musel, right? If you want to explore a standard C library, take a look at the Musel. Right, it's so freaking cool. I'm gonna show you how cool it is. I'm gonna freaking show you. So here is the source code, and it's just a single tarball. Okay, so I'm gonna do wget, and let's just download it. Okay, so let's unpack it. Did it unpack? All right, I think it's already unpacked. Okay, so the one thing Musel does, it actually puts each libc function in a separate file. For instance, you want to explore a function malloc. What you can do, okay, find file with the name malloc.c. There you go. So again, each function is a separate file. You can just grab it, you can just find it and open this thing like so. And there you go. So here is a malloc implementation. So it should be somewhere here. So word malloc, there we go. So this is literally malloc implementation, and you can just read it. It's actually pretty simple, right? It's specifically in Musel. glibc is really painful to read. To be fair, any GNU projects is extremely painful to read, right? I don't freaking know why the fuck they're writing their project like that. Maybe because GNU utilities and GNU projects are used in so many different fucking environments, they forced to actually put a huge mess of macros and stuff like that. But I mean, they don't really have to, right? Some Musel is also probably used in all, like, in a lot of different environments, but it's fine, right? So that's like, look at how simple it looks like literally, okay, this is the signature of the malloc, and this here goes the implementation of malloc, right? So you look into Musel, like, I really recommend to read it. And here's the cool thing about malloc in Musel specifically. I don't really know. Musel is Linux only. Ah, god damn it. But anyway, so here's the really cool thing about malloc in Musel specifically. All right, if your n, the size of the object that you provided, actually exceeds a certain mmap threshold, what it does, it just maps it, and that's it. That's it. Like, it doesn't do anything super fancy. It just like maps it, and there you go. So it only does special things for small allocation. For small allocations, as you can see, it pre-allocates a bunch of like ready-to-use chunks of memory and stuff like that, and it just looks up for them and so on and so forth. But if it's too big, it's just like whatever. It doesn't matter. Just map it. So right. So this is so cool. So to be fair, glibc targets a lot of architecture system. Musel, as far as I know, is targeting. Okay, that explains it, right? So that explains. So because different, you know, to make a code fit into so many different environments, you need some sort of like a stop gaps like all around the code, right? So if devs and stuff like that. Niche OS, right? So niche OS for HTTP servers, right? If Windows is a niche OS for video games, Linux is a niche OS for web servers, right? That's what it is. Anyways, so let's actually go ahead and continue with what we were doing. So I'm gonna open probe OGG, and let's just go ahead and do that. So it's supposed to return some sort of like a pointer to the object. So let's open std vorbis, and I just want to find the name of this object that we have in here, right? So I'm going to call it context, ctx. So I suppose in case of an error, it returns null and sets error to something, possibly to vorbis file open failure, right? So what is that? Okay, so this is a different errors, so to speak. It's an enumeration, and I wonder if there is a function that accepts this enumeration and returns the human readable string. So let's actually find out. Okay, so all right, so error vorb f, so it just sets an error. I don't really see. Yeah, I don't think so. Maybe, do we have like a count? Maybe there's some sort of array. So it feels like they are primarily just codes. There's nothing much we can do in here. But anyway, so if ctx is equal to null, we can just do fprintf std error could not open as. All right, so could not open as, and as is a file path, and we're just going to return like 1. There we go. So the next thing we can do, so the cool thing that Raylib does in here, it gets stb info, right? stb vorbis info, which we can try to print, right? So I suppose this particular structure maybe contains some information, like, well, I mean, it's kind of obvious. So sample rate, channels, right, setup memory required, setup temporary memory, and so on and so forth, right? So maybe this is something that we can do in here. So let's actually extract this thing, right? So we successfully read this file and we are passing it in here. So this is going to be ctx and this is stb Vorbis info. Right, so then we can just print something like a file path is s file path. Then we can print the amount of channels, right? So how many channels we have in here, right? So so it is literally called channels, right? So I can do info channels, and then sample rate is also rather interesting information. So let's also print that thing. So this is going to be a sample. Right. So what I'm doing right now, I'm just like learning how to use this library, right? So I think it's going to be very useful. And all of these libraries, they have a very similar interfaces anyway. Just open, initialize the file, and maybe get some additional information. And also, there's probably a function that just pulls, you know, frames out of the file, right? All of them like kind of have a similar interface. It's just slightly different, right? So let me now try to rebuild this entire thing. No compilation errors, right? So this is build probe OGG, and if I run this entire thing, we successfully loaded the file. So very quickly, actually, if I just run this entire thing, it took us to like how many milliseconds? Yeah, four milliseconds to just open 45 minutes audio file. Right, so this thing doesn't load the entirety of the file into the memory. Like it's just like reads meta information and gets ready to read like more of that stuff. Which is pretty cool, I think, right? So which is exactly what we need. Right, so the next question is, how do you pull some stuff out of it? All right, so you can even get length in samples. This is actually kind of cool, right? So yeah, so you can take the entirety of the length, I suppose, without reading the whole thing. Maybe we should do that, right? So I actually want to see. So let me maybe this is not channels. This is a sample rate. This is a sample rate. Right. So I'm gonna provide the context, right? ctx, and we can printf this entire thing. Length in samples. And what kind of type does it return? That's a very interesting question. It returns unsigned integer, so that means we're going to be using u. There you go. Let's try to now rebuild this entire thing and see what is going to happen. Come on. So this is how many samples we have, right, in the entirety of the file. So this is how many samples the file plays per second. We can go ahead and verify if everything is correct. So essentially, we can take this amount of samples. This is the total amount of samples. We divide it by the samples per second. So this is basically amount of seconds within the file, right? So this is amount of seconds within the file. We can actually do an integer division, probably, right? So yeah, so 2,710 samples, right? So then we can divide it by 60. So that will give us amount of minutes, and that's 45, right? So that's pretty cool. So we knew that the size of the file is 45 minutes, and we actually confirmed that by the amount of samples in here, right? So it's actually super easy to confirm. Okay, so yesu. We did the math. We did the math indeed. Right. So the next question is, how do you pull things? Update music stream. Update music stream. Right. So OGG, and the way you pull, you call this function. Right. std Vorbis get samples short interleaved. Damn, bruv. Damn. So, and does it get it from, we probably need, that's a very intimidating function, like give like from the name and also the amount of parameters it gets. Like it's rather intimidating. Like I'm a little bit scared to actually look into the function. What interleaved means? I suppose it means something about the channels, right? Because if you have two channels, the samples are actually interleaved. Right. So essentially, first comes the sample from the left ear, and then comes the sample from the right ear, and they're go interleaved. And this is how they're stored in the file. So this is like separate channels. That's what it means probably. Yeah, so it is interleaved because LR channels. This is my hypothesis though, right? So, but this is usually how it is with audio files. So, and short means that the size of the sample is 16 bits, right? So that's a very common thing. Yeah, so we already answered that question. I answered the question like at the same time as you asked it, right? So short means that the size of the sample is 16 bits and short is just like 16 bits, right? That's the C type. Vorbis, all right, so do we have in here? Actually, the function itself is not that intimidating. It's the arguments that Raylib actually puts in here. That's what's intimidating. Okay, so I wonder if this sort of like updates some sort of cursor, right? So get samples. Is there any documentation about this? Okay, so the weird thing about this library is that the documentation is actually below the function, right? So I kind of got used to the documentation being above the function, so it's below here. So let's actually read what it says. Gets num samples, not necessarily on a frame boundary. This requires buffering, so you have to supply the buffers. Applies the coercing, I don't know how to pronounce this word, above to produce channels. Returns the number of samples stored per channel. It may be less than requested at the end of the file. If there are no more samples in the file, return 0. I don't fully understand what the fuck they're trying to say in here, but I mean, I think I kind of understand how to use this function. Right, so, yeah. I mean, we should probably just use it. Right, let's go ahead and just use it. So something like that. So we can maybe just supply the context, right? So we can just supply the context. The amount of channels, I mean, we do have the amount of channels in here. So it's basically info channels. And the buffer, we should probably pre-allocate that buffer. So let's actually pre-allocate it in the static memory. So short, so buffer, yeah, might as well just do something like this. So that's the buffer. And how can I, that's bizarre. So this is the buffer, and here I can just use the size of the buffer, but that means that I probably need, though the size of the buffer is what? It's an amount of shorts. Okay, so I really like the use of the name of the variable in here. This is this is so cool. Holy shit. Right, so because like the first question I had, is the size in bytes or in shorts? And the name of the variable, num shorts. Holy shit, like, oh my god. Sean Barrett is fucking genius, right? So he anticipated that question with the name of the variable. Like, what the fuck? It's just like, how does he do that? It's just anyway. So this is the art of variable naming, honestly. This is like a pure art. That is a sensei level of programming, exactly. It's just like, when I read his code, I feel like I'm literally learning different things. It's so freaking cool. Anyways, so this is the amount of shorts, which is exactly what I want. So maybe one day I'll actually reach that level, but I don't really know. Anyways, so let me try to rebuild this entire thing and see if it's going to work. Alright, so I suppose it read something, but let me see. So this is basically the count. Count read. And we can just see how many of them were read. So I've seen people say his libraries are unmaintainable, which is crazy because they're very well documented and simply written. I also don't fucking understand that. It's just like, why? So you can easily like extend things. You can easily like why are they not maintainable? I suppose this is literally just a skill issue. That's probably what it is. It's literally a skill issue. Having this knob is basically a better stdlib for C. I wouldn't say so. It's built on top of standardlib, so I don't know. So it's sort of like a complements it rather. But yeah, it has quite a few useful functions like getting the sizes of static arrays and maybe reading an entire file and stuff like that. So running external commands is also like apparently very common, not only in building process but generally. So yeah, I would say it's surprisingly useful outside of building projects, right? Even though I designed it specifically for making build tools, it is surprisingly useful for making not only build tools, but anything actually, which kind of confirms my hypothesis that building a project is not really that different from developing project, right? The thing that builds your project is as complex as your project itself, right? And because of that, it kind of feels silly that some of the building tools are trying to be simple and avoid being Turing complete, and they still become a mess over time. I feel like the thing that should build your project should be Turing complete. It should be Turing complete. Right. And I don't know where I'm going with all that, but yeah. So the build tool is just as complex as your project, right? So that's what I was trying to say. I don't know where I'm going with that idea, but anyways, so what I wanted to do, I wanted to actually maybe just print the things, right? Just print the thing. So the thing that builds your project should be your exactly. That's a better one. Thank you thank you. Similar to that OS, you check. Yeah, exactly. Right. So it's like it has to be like a full-fledged, powerful project. So the thing that builds your project is your project. Yeah, exactly. It is your project. So that's what it feels like. Jai builds are my favorite way any language does build. Yeah, exactly. That also confirms that, right? So the thing that builds your project should be your project, right? So Jai only confirms that even more. Self-sustaining, yeah. Yes. So what I was trying to do, I wanted to just iterate how many of these things we read, and maybe I'm gonna just try to print them. So how many? So reading 1 kilobyte is actually kind of too much. Let's actually read 5. Let's read 5. And since it's 5, I can just allocate it on the stack. Yeah, I can just allocate it on the stack. So print f, and this one is going to be, let's say it's u. Maybe I'm going to put a space in here. Buffer I, and at the end in here we're going to just put a new line. Why did it switch to Cyrillic? For fuck's sake. Alright, so let me see. So we didn't really like... It's only read 2 of them? Seriously? What the fuck? Comparison of count... Okay, so that's bizarre. So I was told that it may read less than available. So maybe that's what's going on in here? Okay, what if I read this entire thing the second time? What if we read it the second time? Or, actually, why did I copy paste it when I could just, do outer loop? Right, so this is going to be j+2 ++ j. Alright, and let me try to do that. What if I read it 2 times? Am I... That is sus. What if I put 10 in here? It reads half of them? It's interleaved and shit. I completely forgot about that. It's interleaved, so we have to take into account left and right channel and everything. So that's why when I read 10 of them, it actually read 5 of them. So, okay. So that's kind of funny, right? So let's read it one more time. So gets num samples, right? Not necessarily, not necessarily 1 frame boundary. This requires buffering. Ooh, this is num shorts. Returns the number of samples. It accepts the number of shorts, but returns the number of samples. Okay, okay. So what that means, chat, we have to multiply this entire thing by info channels. And to be fair, it would be better to actually pre-allocate this. So we're pre-allocating 10 samples, which is amount of, okay. And since this is the, all right. And this is the amount of shorts. Okay, so we need to take into account the this kind of thing. Okay, so that's very cool. That's very cool. So samples count. Right. So this is a samples count. Samples count. And if I try to do that, there we go. So that seems to be working. That seems to be working. So we're reading like by 10 samples essentially. Are we reading by 10 samples? Yeah, I suppose. And so that means this is basically 20 of them. It is in fact 20. Okay, so as you can see, there is currently silence, right? So my hypothesis is that if we read long enough, at some point we start hearing things. Okay, so what if I read 100 times? At which point, actually, yeah. So if 1 second is 48 thousands of those motherfuckers, this is not even close. We have to read fucking a lot. We have to, like, this is 200 words, right? It's not even 1 second, honestly. This is not even 1 second. So I have an idea. What if I just make it an infinite loop, right? And I run it not really from Emacs, but rather from the terminal, right? And we'll see how it is going to just like at some point it's going to be 0 and then it starts showing the samples, which is basically it's playing something, right? Right, so let's go in here and I'm going to just do cd and I'm going to just do probe OGG. Yeah, it's almost instantaneously started to show some things, which is kind of funny, right? So some of these samples are huge, and this is because I suppose shorts are like can be negative. They apparently could be negative. Okay, so what if I just switch it to D by allowing that? Okay, so yeah, at some point it started to do that. But if I take a look at the head of this entire thing, it's initially like 0. But if I do like 100, so what about 200? What about 1000? Yeah, so after 1000 it starts to do things. At which point though? I'm curious. So yeah, but I mean, so that basically slowly pulls all of those things, right? So my hypothesis is correct. Okay, so we can do that in isolation, right? So in isolation from Raylib, we can just use stb vorbis and we can, you know, slowly read OGG files pretty quickly, right? So we don't have to load them into the memory, we can just slowly read them. That is totally fine. So we can create our own abstraction that is similar to the Raylib music, right? So to the Raylib music, let me find the raylib.h and let's find the music, right? Which is going to contain some sort of a context, maybe CTX type, and maybe the amount of frames and stuff like that. But it's going to be our abstraction, right? And we will know what kind of, to be fair, we already kind of know the context. Honestly, the context type is exposed to us. Look at that. The context type is exposed to us, and we already have the music thing opened in here. That probably means we can directly manipulate this thing. We can directly manipulate this thing and read ourselves. That's actually kind of cool. Because we know for a fact that this CTX data is that object from one of those libraries. So we can cast based on we can already cast based on types. So the fact that Raysan actually exposes the type for us is actually super good. So it's not that opaque. I didn't realize that actually. It's not that opaque. So one of the things we can do when we start rendering, we can just reset the cursor, whatever the cursor is used by whatever library, and just like poll the things ourselves. And we don't even have to write the polling code ourselves. We can just steal whatever is in update music library, right? Update music stream, right? So just go into the update music stream, and there is like a huge switch case or if else, whatever, right? Just take that and adapt it to read this kind of stuff into your buffer. Like right now, it just reads it into the system global buffer. Just hack it to read it into your buffer that you provide. Okay, that's actually kind of cool. And the question is, how do you reset the cursor of the music, right? So as far as I know, if I take a look at the plug.c, how do you reset? So there are things like a set music, just a second, Raylib. Play music stream. There was a way to set seek music stream, right? Seek music stream. So we have that. If I take a look at this thing, all right. So basically, each library has its own seek function. Dr. Wave seek, std Vorbis seek, Dr. MP3 seek. Right, so they can actually, yeah. So for each library, for each kind of file, you can actually just seek differently. But how do we restart the whole thing? So I suppose to restart the whole thing, we have to stop the music and then start it again. So when I'm stopping the music, what exactly do I do? Oh, okay. So stopping the music just seeks it to the first frame. Okay, so this is... To be fair, I can, before rendering, what I can do, I can stop the music. I probably already stopped the music. Right, so start rendering track. I already stopped the music. Okay, I already stopped the music, which effectively already sets the cursor to the beginning. And as I render, I can just pull the frames, maybe with update music stream. But interestingly enough, yeah, I think the only custom thing that we'll have to write is this function that pulls the frame outside of integrating with the global audio system. That's the only thing I'll probably have to do. All right, that's actually super cool. All right, so I think I kind of know what I want to do in here. So, all right, so we're already streaming for 1 hour. I think I'm gonna make a small break. I'm gonna refill my cup of tea. And after the small break, we're gonna actually go into implementing this entire idea. So on the first part of the stream, we were basically gathering information about how Raylib works and stuff like that, and what we can do with this knowledge. And now I can see that, yeah, well, we can actually do quite a lot. We're making a lot of assumptions about how internally Raylib works, but that is fine because we're vendoring Raylib source code into our project. So we don't care if something changes in Raylib because we have our own copy of Raylib in here. Maybe we're gonna be stuck with Raylib 5 forever and gonna keep maintaining it, right? So this is something that we can do, right? So far, I don't feel like I need more features from Raylib, so I can basically freeze the version of Raylib, and if I need something more, I can just add those features myself, right? So just like enterprise development. Yeah, so actually I've worked in enterprise projects where people literally do that. So you can just rebase from main Raylib. Yeah, as well, we can do that as well. So I worked the project where we were using like our version of the library, right? And we had a bunch of patches that we were rebasing every time a new version comes out. Sometimes we would actually wait a couple of versions because rebasing, we were too lazy to rebase the patches, so it was just easier to use the older version. So just vendor all the depths in your source repo. Honestly, that would be perfect. It would have been perfect. Anyway, so let's make some break. And okay, so let's go ahead and maybe take this function that updates music stream, and take this stuff and factor it out. So, so they do this kind of stuff in this for loop. Check both sub-buffers to check if they require refilling. Sub-buffers? So, what the fuck are sub-buffers? It's just like for left and right channels or something like that? That's what's going on here? That's kind of bizarre. So, and also when it's audio wave, we look at the sample size, and if it's 16 we use one function, and if it's 32 we use another one, which makes sense. Okay, that's cool, that's cool. So so stb verb is seek start, and then we restart, and so on and so forth. So on and so forth. And I wonder where is the conversion going on, because obviously different files may have different formats and stuff like that. They may have different formats, like where we do the conversion to normalize all of that. That's actually very cool. The back buffer and the front buffer. Maybe that's what it is. And let's take a look at our application. Right, so when we are doing the rendering, the actual rendering, so if we are currently in the rendering, we are doing the rendering screen. In the rendering screen, what do we do? So this is when the rendering is already finished. This is when the rendering is cancelled. And this is where the rendering is going. Okay, that's very interesting. How do we process all of that? So this is just drawing the progress, nothing particularly interesting. And this is where we processing the samples. Okay, so these are the samples. And they are floats. So when we're loading wave, they are normalized somehow. So as you can see, I literally had coded casting to floats. So that means I assumed, for whatever reason, that load wave just normalizes everything accordingly. Okay, so let me actually see what is going on with the wave. Alright, so this is the buffer data, bits per sample. Did I convert some stuff? That is rather bizarre. Why did I make so many bold assumptions? That is very interesting. So load wave samples. So this is just, and wave samples are what? Aha, that's who does that. That's who does the shit. It's probably load wave samples who normalizes the shit. So load sample data from the wave as 32-bit float data array. Not only I duplicate music once by loading wave, I duplicate it twice by actually converting all of that to floats. Holy shit. How are you supposed to render long music like that? It's insane. Like so many freaking conversions. So many freaking conversions. That's interesting. Okay, so let's take a look at the implementation of this function. What does it actually do to do the conversion? Right. Oh, it's like it's converting this shit in place. What the way? That's so fucking funny. Like, okay, it allocates enough for all of these frames and stuff like that. Then it just literally iterates them, and depending on the sample size, it just like does different formulas. Okay. That's really funny. I like that. I actually like that. Yes. So maybe this is something that we're going to be using, right? At least this kind of formula that we're going to be using in here. Okay. Because the function that I want, honestly, the kind of function that I want should probably look like this. So poll samples from music, and it's going to just accept the music like this, and it's going to accept the buffer, right? So it's going to be the buffer, and in here we can say, so maybe we're going to use the trick from Nothing's book and say num floats, right? So this is, wait, I saw out the completion actually doing that, right? So I guess in games it makes more sense since you would load it at once at startup. For music player, not so much. I guess so, but I mean, Yeah, maybe. Right, it's just like depends. And so here we actually want to kind of load everything, but then stream a little bit. You're talking about like iterating the entire. You're talking about this implementation. I already forgot about it. My thoughts actually wandered in the future. So thank you so much, Mr. Realm Grinder, for Twitch Prime. Thank you, thank you. Right, so I guess it does make sense, right? So I guess it does make sense. Okay, so we pull samples from music, and I want this thing not only to pull the samples, but also to automatically convert them, right, to whatever they are. So I don't know if we're gonna return anything in here, right? So, but we'll see, we'll see. So update music stream. Where is this function that updates the music stream? I suppose I'm going to simply ignore these sub buffers things and stuff like that. The only thing I'm kind of interested in is this switch case, right? So I really don't care about anything else, right? So this is going to be the switch case. Now I'm going to just copy paste this entire thing to here, and yeah, so let's just put it like that. I wonder if this music audio wave is available within raylib.h. No, it is actually hidden from us, right? So this is one of the things that are straight up hidden from us. Right, so 1, 2, 3, 4, like so. Too bad. So we also probably don't have an access to these kind of things. So that's gonna be interesting. That's gonna be interesting. Anyways, so let's actually go ahead and try to compile this entire thing. I'm gonna go into the knob, maybe src build stage 2. So let's remove, maybe comment out building of that prop OGG, right? So we just played with this library a little bit to get the gist of this library, right? So now we know, now we understand this library. Let's go back into building the whole visualizer and see how it goes. All right, so yeah, we forgot to actually remove that one. Let's go. So I expect it to fail, right? I expect it to fail. Okay, so it calls actually this thing music, so let's follow the convention so we don't have to rename too many things. All right, all right, all right. Okay, so that's pretty cool, and this is probably because it removed all of these cases because none of these things were defined. Okay, that's very interesting. So, but that gives us a very interesting opportunity to maybe just define them like that and slowly, gradually add support for all of these things. This is actually kind of cool. So I can do define support file format format wave, right? So, and that will enable this case in here, right? So because I suppose this is sort of like an internal macro that is only visible within the source code of Raylib, and it's definitely not defined anywhere in raylib.h, right? So as you can see, we can't see it in here. So because of that, all of that got disabled. But now we're gonna like slowly enable one format and see how badly it's going to fail. All right, so it fails somewhere, and it fails with not being able to find music audio wave. So let's actually find where within the Raylib it is defined. So this is going to be something like that. So let me actually, maybe we can do RG. So people told me that I'm supposed to use vim grep if I want the format that is parsable by Emacs. Vim and Emacs, like they use kind of similar formats. All right, so I suppose this is where, okay, so this is the enumeration that we probably need, and it's an internal one, unfortunately. It is an internal one. So music context type depends on the data structure provided by the library in charge of reading in different file types. Okay, so I think I'm gonna make a bold move and just like literally copy paste an internal structure into here, like so. Right, because we're vendoring the source code of Raylib, we can do whatever the fuck we want with the source code, right? So according to the license, of course. So one of the things, by the way, the license requires us is that if you basically like distribute modified version of Raylib, you have to explicitly state so. If we're vendoring Raylib, we kind of like distributing the version, the source code of Raylib in that sense, right? So if I add any modifications to Raylib, I have to explicitly say that it's modified. But to be fair, copy pasting chunks of Raylib into our project is not really modifying the project per se. So Yeah, I don't know, right? And this thing may change in the future versions, right? So, for example, if internally Raysan just swaps around some of these things, our code is going to break, right? Because the order of the numbers is going to change in here. So, and these two structures are not synchronized. It would be better, honestly, if this enumeration was public. Which is kind of bizarre, isn't it? Because the type of the context is public, right? So CTX type is public. But the reason it is public is probably because there's nothing much you can do about that in C, right? So because C doesn't have private fields, right? So, and you need some sort of fields that indicates the type of the context. So that's why it's public. It's not intentionally public. It's just, you know, because of C, right? But honestly, it would be much better if this enumeration was public. Right, that would be much better, in my opinion. But I mean, it's up to Raysan to decide. Anyways, so we can copy paste this thing. So wait a second. I wanna copy paste it one more time because I was changing the order of some things, so I don't want this thing to break. And now let's try to rebuild this one more time. One more time. Just a second. So what's the next problem in here? Okay, so we're having a little bit of a problem in here, right? So what I'm thinking, we probably need to allocate the buffer of the same size in here. So sunny. Yeah, so it is pretty sunny outside. It is in fact pretty sunny. So how are we gonna be doing all of that? We can just do you know, malloc. So how malloc is done? So they usually do something like rl malloc, right? So for example, in load wave samples, so this is basically what they do, right? So it's sort of like an intermediate thing, and then they just return this entire stuff. Maybe this is what we can do in here, right? So I'm gonna just do that, and what we want to allocate, we want to actually allocate num floats, right? So this is a num floats, size of floats, and this is basically the buffer. Maybe let's call it samples. But we're not going to be allocating floats, we're going to be allocating shorts. Right, so let's replace it with short. This is another short, and this is another short. And then we should not forget to, you know, how is that called, to deallocate it? But we're going to be calling it basically on each frame. So allocating and deallocating shit like that is not a good idea, honestly. It should not be a good idea. So here is an interesting stuff. You should not need to convert integer samples to normalized floats in your case. I should. I know my case better. I know that I should. Because we support a lot of different formats, and a lot of different formats will come with different size of integers, and we don't want to have a huge switch case all over our source code. We want to actually convert it to normalized once and forget about it in the rest of the code. So Tukan work, thank you so much for tier 1. Thank you. So let me actually think. So it would be better to not like reallocate that over and over again, right? So that is kind of dumb. It would be nice to have some sort of like a temporary buffer into which we can just push some stuff. So I don't know. So num floats. I haven't decided how we're going to be doing all of that, because we're going to be doing conversion, right? So depending on what kind of stuff we have in here, we must do, we just read the chunk and we have to normalize it. and that requires like 2 buffers actually, but I mean the caller doesn't know what kind of buffer you need in here. So, and doing malloc over and over again is kind of like meh. It's actually kind of meh. So I don't really know how we're gonna approach this entire stuff. So it would be maybe nice to just supply something like knob string builder or some sort of a buffer, like some sort of a buffer into which I can just like allocate some stuff and I could reuse that buffer, so to speak. Or maybe some, okay, so I can probably use some sort of an arena. Right, some sort of an arena. Like so. So here is an arena. And I will just allocate some stuff in there. And then reset the arena. And allocate again and again and again. So that kind of makes sense. Right, but I do not have arena in here, so I probably will have to get that arena from somewhere. That's a bit annoying, right? So this is the case where I have to allocate different arrays of different sizes depending on the internal format, and the user doesn't really know much about it. So I have a pull request in here. I don't remember receiving pull request. Arenas biased. So where was it? Opened last week. I don't remember this. Let me see. Arena bytes function that counts up how many bytes are allocated in the arena. Okay, so it's just basically gathering some information. I see. Is that useful? I'll think about it. I'm not sure like what to think about that. Anyways, so we need to grab the arena and add it to the source code. I just want you to get the role. What, inviting freaking GitHub? Sometimes I think sometimes website should just shut the fuck up. Like honestly, why modern websites can't stop fucking yapping? Like I want to download a fucking file. What the fuck is going on? Just shut the fuck up and let me download the file. All right. You have only one job, is to just shut the fuck up and let me download the file. All right, so let me take this stuff and I'm just gonna put it in here. MS website, yeah, exactly. But there was some sort of problem with UI, like accidentally the focus slipped and stuff like that. But I don't know. But to be fair, generally Microsoft software is very yappy, if you know what I'm talking about. It is insanely yappy. That's probably why they really liked ChatGPT. That explains it. That explains why Microsoft loves AI and ChatGPT so much, because like generally all the Microsoft software is very yappy. Yappy. Anyways, so what we're gonna be doing here, is just like you know, arena alloc. All right, and that's it. So I don't even have to worry about it too much, right? So because then it's up to the caller of this function to then clean that arena and so on and so forth, right? We don't give a scheißung. All right, so let me try to recompile this entire thing and see how it's going to fail. It's probably going to fail with, like, I don't know what the fuck is arena. Like, I mean, just include that shit. Right, so let's just include it. Arena.h and, yep. Look at their latest feature recall. Yeah. That is very funny feature. That is a very silly feature, I would even say. Did they reconsider actually including that feature in Microsoft Windows? Right. So because I feel like they got a pretty bad backlash about it. So I would expect them to reconsider. But maybe Microsoft actually grew so fucking big that they don't give a shit anymore, right? So they can just force that stuff on other people. It's off by default now, as far as I heard. Okay, so that's actually kind of cool. So, yeah. I agree, Microsoft doesn't give a shit. By the way, so speaking of big companies not giving a shit, is the Google AI still a thing? the reason why I'm asking is because I live in Russia and I literally don't have an access to this AI thingy. So all of these memes, I know about these Google AI memes, like literally from Twitter and screenshots. Is it still on? Is it still working? Right. So is it still on and is it still working? So because I don't really know. So because it's kind of interesting. If I remember correctly, some time ago, it's still what? Nobody. It's still on. Okay, okay, that's cool. Because I remember some time ago when Google was actually a smaller company, one of the things they were trying to do with their search engine is to actually embed parts of the content of the website to the result page, which resulted in a less traffic to the website themselves and a huge outrage. So the website owners started to sue Google for that, and the Google backed off, so they never did that again. So this AI responses thing is basically a version of that, but this time they're so big, they're so powerful, they don't give a shit. Isn't that insane? How in the past they couldn't get away with that, but now, since they're Google, they can get away with that. That's fucking insane, isn't it? It's just like they grew so fucking huge, like, yeah, we don't give a shit. What you gonna do? Class action lawsuit? Bring it in. It's just like, what you gonna do anyway? Your website is dead now. You have no money. Fuck off. So yeah. It's kind of bizarre. So they couldn't do that one time. They waited a little bit. They tried it again and they won. Didn't they just trust the win their antitrust suit too? I don't really know. So anyways, what do we have? What do we have? And I also need to have an access to Dr. Wave now. That's very interesting, right? So since I'm like touching these libraries directly, right, I also need to include that stuff, which is, to be fair, fine. Right, I can do that. So I can just do external Dr. Wave .h. Dr. Wave.h. Right, what do we have in here? So now we are kind of referring to the variables that we don't have in here. So frames count still needed. Let me take a look at this specific function in here. So this is going to be Raylib, src, external, Dr. Wave. All right, so what do we have in here? Right, so, so this is what we have. We're just reading these things. Frames to read, and this is a buffer out. But what is frames, right? Is the frames both channels, I suppose, right? So it is both channels. It is both channels. So I suppose I can just do something like that. Num floats, right? Since I accept floats, that's what I do. But then how many channels do I have? Right, so I can go raylib.h. So this is going to be music. Do I have channels in here? I have frame counts. So maybe this is something that I can find in audio stream. Right, this is what I can find there. So this is going to be stream. Where all that? Music stream channels. Music stream channels, and this is the buffer we're reading into, right? So the samples. Okay, so that's what we got. Frames count to read. So it also does. So it also then resets this entire thing, but I don't think this is what we need in here. Right, so we can just like do it like that. So we read some of this stuff. One of the things we probably have to return, by the way, is how much we actually read. So that's very important, actually. That's very important. This is just needed for looping. Yeah, I figured. So, but we don't really care, right? We don't really care about looping. We're just trying to read some stuff for, you know, for visualization. So it also does that in while true loop, right? Which I kind of sort of like skipped. Let me try to see what exactly it is used for. Update music, because I already removed that code. Update music stream, and in here, so count still needed. So, so I suppose it has how much you need to read, and this is how much it actually read. So, and then it kind of, ooh, that's very interesting. If you trying to read more than there is actually is, it loops around. That's why it does that. That's why it is in the while true. That's very funny. Right, so it reads like past the end, but what it reads past the end, it just wraps around and gives you the beginning of the song, right? So that's what it does. So essentially, you have some song in here. You want to read this part, but this is the end, right? So you say, okay, read 6. It gives you 4 plus whatever 2 you had at the beginning. So it will give you that. All right, so and just because of that, it effectively loops around. So that's probably what's going on. We don't really need that, you know, when we're rendering. So I suppose we can just do something like this. All right, so that's about it, I think. And so we get the samples, right? So we get the samples, and one of the things we want to do now, we want to convert them. So to convert them, we can use whatever load wave sample is using, right? So this is the formula that we're talking about. So since it read the samples, right, so we're going to be iterating, not really samples, the frames, right, so we're iterating the frames. Frame count read, so this is what we read in here, but then we have to multiply it by the amount of channels, right, so we multiply it by the amount of channels. So that's what I'm doing in here. Okay. So do I have a sample size in here? Do I know the sample size? I actually do know the sample size. So the sample size in here, as you can see, is exactly 16, which means that that's the formula I must use in here. Right, so I take the samples, right, so maybe, that's a bit bizarre. Samples, and then I convert it to float, and then I divide it by this maximum in here, right, and I assign it to the output buffer, and that's it. That's what I need to do in here. That's what I need to do in here. Right. So, and if the sample size is 32, I probably have to do a similar thing in here, but I have to do the different conversion. Actually, not really, honestly. Since it's already 32, I don't have to do any conversion. I can just like directly read it into the buffer. So let's actually try to compile this entire thing and see what is going to happen. All right. So it didn't like that I used arrow in here because it's not a pointer, right? So that makes sense. So now, yeah, that's another one. Okay, so I suppose now it complains about only this part, right? It complains about only this part. It's kind of interesting that in case of a wave, it cannot be anything but 16 and 32, right? Isn't that bizarre? So I suppose maybe this is something that Dr. Wave guarantees. Maybe, I don't really know. But anyway, so now it complains about the second part in here, so let's actually try to adopt it. So since this is just a float, we don't really have to do that anymore. So let me actually convert. I'm gonna go into the Dr. Wave, find, yeah, it just accepts floats. This is perfect. So what do we do? Num floats, but it reads frames. So that means, can you see, this is actually very annoying. I'm not sure if you can, I think you can see that. All right, so we're dividing it by this stuff. Maybe it makes sense to actually factor these two things out into something like num samples. Right, so num samples, and num samples is basically that. We take num floats and we divide it by the amount of channels, and that's what we want to read in here. That's very cool. So this is a num samples, and then it just takes this weird pointer. So we are going to be actually putting buffer in here, and I think that's about it. Actually, we don't need that. So we just return frame count red, and that's another thing we have to do in here. And also get rid of the infinite loop. So the funny thing is that what we actually need is much simpler than whatever update music stream is doing, right? So if you take a look at the update music stream and what it's actually doing, it's doing a much more complex thing than what we actually need, right? And because of that, we're removing a lot of code in here, right? What we just need to read a chunk, and that's it. Just give me a chunk, no more, no less. Funnily enough, what if it's actually something else, right? It's not going to break. It would be kind of nice to maybe put something like, I don't know, unreachable. So assert unreachable. Do we even have a notion of unreachable? We actually don't. But maybe it's not a particularly great idea. Honestly. So I don't really know, because it's kind of a dangerous thing, right? It's kind of a dangerous thing. What if accidentally you got a music that has a sample size that is neither of those things? What do you do in that case? I think we should try to do unreachable, and then I should put it to do something better with that. Maybe report an error to the user or something, right? So because we don't want to have that in a production where if the user just put like a really weird thing into the visualizer, it just breaks without explanation, right? So we don't want to have to do that, but it may happen. So it would be nice to somehow handle that properly. You know what I'm talking about? Yeah, you know what I'm talking about. Anyways, so let me try to now compile this entire thing, and hopefully it is going to compile. So the warning control actually reaches some stuff. Interestingly, maybe what I want to do is put unreachable actually down below. All right, so unreachable down below. So it's going to be 0 for now. So we don't return anything. And let's just return that. Okay. So undefined arena alloc. That is understandable. This is because we need to enable implementations for the arena. Arena implementation. So now it should hopefully work. We'll see. All right, so we have now implementation of poll sample from music that works for one format. So, and this is already kind of good, honestly. This is already kind of good because then I can iteratively add more and more formats in here, right? So it supports only one, but that is totally fine. That is totally fine. If we can make it work for one format, we can then slowly make it work for the rest of them. So one of the things we need to do now, we need to integrate that polling, that Rolly polling of the samples into the main rendering thing. So how we can do that? We can do that using compiler assisted refactoring by maybe literally getting rid of all of this stuff, right? So because this is where we used to store the samples. Now we don't need this thing anymore because we can take those samples directly from music stream. So let's actually comment them out. That will break in a bunch of places, and these are the places where we need to make modifications. So that's how we do things. That's how we do things. All right, so as you can see, it broke in a bunch of places. That is understandable. So I even had to do for that. Holy shit. Right. And I think I created this to do like right away after I even implemented this entire thing. I kind of anticipated that. So it's been on the back burner for quite some time. So, and I finally got around to actually fixing that. So this is super cool, I think. Right. So we don't need any of that stuff, right? So I'm just removing it. Next thing. Where else are we breaking? Okay, so, and this is another thing, when we're done rendering, we are kind of unloading all of that stuff. Since it doesn't exist, there is nothing to unload. So let's just remove that. To be fair, I don't really know why I commented it out, honestly. I'm using control version system. So if I need to recall what was that, I can just take a look at the diff, right? So I don't really know. Keep forgetting that I'm using Git. Keep forgetting that I'm using Git. Okay, so this is cool. So here we are checking whether we reached the end of the frames within the music. So since we had a wave, we kind of knew the amount of frames in here. So this one is rather interesting because maybe that means we need a wave cursor. Right, so I removed the wave cursor like along with everything, but it feels like it's still needed, right? So because we need it for this kind of like, you know, thing. Or maybe music has a function that checks that we reached the end of the music. I don't really know. Let's find a place where we have all of the musics in here. So is music still playing? Stop music. I don't think it has anything, honestly. We can get the time played, but it's like in floats and seconds, so it's not particularly reliable. It's not in frames or anything like that. So I don't think we can have a direct access to the cursor in here. So yeah, I think we need to maintain our own cursor. So let's actually revive wave cursor. Let's actually revive it. So I'm going to just, you know, do something like that. And maybe I actually removed. Okay, so this is another thing that we need to revive. Right, so wave cursor. So do we use wave cursor anywhere else? Nah, it's only 2 places. Okay, so that's cool. That is very cool. That is very cool. So let's try to recompile it one more time. And what do we have in here? Would not seek music return null or something if end? Seek actually sets the cursor, not gets it, isn't it? I don't remember actually. Let me see. Seek music. Yeah, it only, and it actually seeks in floats in seconds, right? So using seconds in here is not really reliable because we are doing a very fine-grained work. We're working on a level of individual frames and samples. That's how like that's the level of resolution we're working with. So this API only allows like very loosey seconds in floats, and this is not what we need. It's not reliable for what we're doing. It's not reliable for what we're doing, so we're not going to be using that. Okay. So now when you grab the samples, it should return 0. Maybe we could do that, but this is not the moment where we read this kind of thing. So our code is not structured to do that, unfortunately. So using that means that I have to heavily restructure the code, or at least I don't see how to restructure it easily. So I'm just following like the flow. I'm just following the flow. It's not the problem. It's like you're hyper focusing on not important thing. Okay, so this is a wave frame count. So this is music. I think it's track, right? P track. Okay. So what's the current track actually? So we have a notion of a track. Okay, so that's pretty cool. And when this entire thing is going, we know that the track is yeah, it's not null, right? So we have an assertion for that. The track is not null. That's pretty cool. So that means I can just do track. And within the track, we have music. All right, so I can just do music. And frame counts, music. Yeah, frame counts are available right here. That's cool. All right, so that's actually fixed. That's actually fixed. That's pretty cool. What's the next thing? Unloading, not needed. another unloading. Oh, we have a little bit of duplicate code, right? So we have a starting rendering, but we haven't factor out finishing rendering, right? So we just have a little bit of a code that we always do when we finish rendering, and I haven't factored it out. But that's fine, there's not that much of that code. I think it's like 2 or 3 times. At some point I'm gonna actually factor it out, so it's no big deal, no big deal whatsoever. All right, so wave cursor, that's pretty cool. So this is just basically track, music, frame count. What's the next thing? Sample rate, that's very interesting. Do I have a sample rate in music in here? I suppose it's somewhere in the audio stream. Audio stream. Yes, we do have that. So we have to do track, music, stream, sample rate divided by the render FPS. All right, so that's cool. Okay. So this one is interesting. So we take a look at the samples, right? So this is the samples we're working with. I see what's going on in here. So this is the chunk that we need to process. Oof, that's very interesting. That is very interesting. Because we need to load that frame. So this is where we have to call this function now. So we need to have this arena somewhere. I'm going to allocate that arena within the plugin state. So how I'm going to call it? Maybe I'm going to call it like a rendering arena or something, right? So rendering arena. And obviously I'm going to pass it by that. So we also provide the music. So this is a track, the music, and the buffer. Though we can actually kind of pre-allocate that buffer, honestly. So yeah, so this is a sample rate. So we can do buffer, then arena alloc. We're just using the same arena. It doesn't exist yet, but it probably will at some point. So the chunk size is basically not really num floats, it's amount of frames that we have to read in here. So that means we have to allocate chunk size multiplied by the amount of channels, right? So that means we have to take the track, music, stream channels, right, and also multiply it by the float. We can actually multiply it by the size of the buffer element. So this is basically what we want to allocate, how much we want to allocate in here, right? So we pre-allocated the buffer. That's pretty cool. So now I'm just doing that, and then I'm gonna say that I want to actually read chunk size multiplied by the amount of streams in here. There we go. So that's pretty cool. It's kind of interesting that I'm using arena to allocate the like this buffer and also a bunch of internal buffers as well. So I'm getting consumed by the camera. This is because I have a lot of light behind me, right? So it's very sunny today. I wonder if I increase the light like this, am I less consumed by darkness? I think I am. Let me actually see that for myself. I think, yeah. So it's now very much balanced. So this is basically amount of sun you get in Siberia, right? But I'm actually getting blinded by my lamp right now. So that's what's going on. Anyways. Hopefully that is better. Yes. So rendering, okay, it was fine. Okay, so what do we have in here? We don't have a rendering arena, which is perfectly understandable. Let's actually introduce it. So plugin. So where are we gonna put that? Maybe somewhere here. Arena, rendering arena. So now we do have a rendering arena. So what else do we have in here? So here are the samples. Honestly, this is just the buffer. This is literally just the buffer. No. That is just the buffer. That is just the buffer. Okay. So, so we have a wave cursor. So what we have to do, honestly, we just have to do I. So that's that. Yep, that's literally it. So, but we have to use the different thing for the channels now. Right, so this is the channels. It would be better to actually factor out some of this stuff to like variables, right? So look how many times we use that. It would be better to just say channels and then say, okay, this is channels. So yeah, that's much better, honestly. That's much better. What else do we have in here? So frame count. Frame count. So this is a sample rate. So this one is a track. Music string. No, not even frame count is available within the music, so we don't have to do that. All right. So what else do we have in here? All right. Okay, we did that. So we integrated this thing into all of that. To be fair, I would rather say that this is going to be a fast count. Let's call it a fast count. So we're iterating, not really. Oh, what's funny is that it doesn't even fucking matter. Like, we don't care how much we read. We literally don't. Honestly. We literally don't care how much we read because we're gonna fill the rest of the stuff with nothing. Yo, that is actually kind of cool. Because now, what if I just mem set this thing with 0, right? So size of buffer multiplied by, well, I mean, I can just take this entire thing. All right, so we just fill all of that with silence. We just fill all of that with silence. So because if we overflow, and yeah, that makes sense. That makes sense. So if wave cursor, it doesn't even fucking matter, honestly. We can simplify it like so. Right, because if it read less than needed, so the rest is going to be 0 because of this previous mem set. Yeah. So, and this one is kind of redundant. Might as well just call it buffering here. So that's much simpler. So that's pretty cool. So I'm just looking if I made any mistakes in here. I don't think I did. So that's it. That is it. So, but this code will only support waves, right? So it only will support waves. One of the things I probably want to do, if we encounter something like, I mean, we'll already say that it's enrichable, right? So that's fine. Might as well. So asserts are not particularly convenient in here because they are disableable, right? So let's actually do something like fprintf std error unreachable unsupported format. So unreachable unsupported format, and I'm gonna literally abort in here. Abort. So instead of abort, say abort. Or I'm sorry. So yeah, so now this thing is not disableable. Abort. Okay. I want to try that. I really want to try that. Oh, of course, semicolon. Sure. So I'm going to first try with OGG. I'm going to simply do this kind of thing. All right. Seems good. Seems Gucci. OGG. It is playing the music. Right. So, which is expected, which is totally fine. Now, if I try to render it, it should crash. It crashed, and what does it say? Unsupported format. Exactly, because we didn't add support for the OGG. But we do have support for wave, right? So that's exactly what we were working with. Let's actually see if we can render wave and whether it is going to be correct or not. Do I have any waves that are easy to just slap? Oh, all of them are OGGs. Bruv. We have to convert them, I suppose. We have to convert them somehow. So can I find some very small sample that is super quick to render? So let me see. I think that one, this is my favorite. Yeah, I really like this one. So I liked it so much that it became sort of like a demo of the music. So yeah, so I swear to God, Null is a genius, right? So if you want to actually discover more on the songs of the same artist, like actually check out these links, right? So this is a song. So that's the author of this sample. So let me go to this specific place, and maybe I'm gonna actually do something like that. All right. So I want to convert this thing. Null is a genius. I'm telling you, he's a genius. So how can we convert that? And recognize, and he's so insanely underrated. Like, oh my god, just like if you look at any of his socials, like he's extremely underrated, and it's a huge crime. It's such a huge crime. I swear to God. Anyway, the modern internet, it fucking sucks. Like, the way the modern internet works absolutely fucking sucks. Some clowns, some loud clowns always get on top, and genuinely like talented people, like nobody fucking recognizes them. Anyways, so let me see. So that seems to be like a wave. All right. Okay. So maybe now we can try to do that. So let me see, and wave, right? So okay, so if I try to render the whole thing, it is rendering, it is doing something, right? So which is nice. Does it get any data? It's actually going really slow, honestly. It is going slower than I would expect. It is going slower than I would expect. Is that because... So I remember there was a pull request somewhere in Visualizer that suggested to uncap the FPS. Right, because right now so something about FPS. Yeah. So essentially, because we're doing that on each iteration of event loop, and that is intentionally slowed down to maintain a certain FPS. So one of the things somebody suggested is to just like set target FPS to unbound before rendering anything, which is a good idea, I think, and it may speed up this kind of stuff. But the thing I want to do right now, I want to wait until it actually finishes rendering. Yeah, that's pretty smart. Yeah, so I should probably accept that pull request. I don't remember. Yeah, I think it was in the form of a pull request. Yeah. I want to first check if this works correctly, at least. And then we can try that idea of unbounding FPS. Because it's slow, but it's not that slow, right? We can wait until it's finished within the stream. So it's like 20 seconds. Yeah, it's going... Honestly, it's going like a 20% of the playback speed, so... Unbound power. We now have this this button which allows you to cancel this thing, but we're not going to cancel it. All right. Are you done? Are you done yet? Hope you're done. It's still going, right? So that means it has a little bit of a stuff in the buffer. Okay. So, and it didn't break throughout the process, right? So it finished correctly. So that means we're probably doing something correctly. Okay, so let's actually... It just worked, surprisingly. So I didn't expect that. So, all right, so let's try to unbound the thing. I want to take a look at the pull request. I think it was in the form of a pull request. So I really apologize that sometimes I don't look into pull requests and issues. I have a lot of different repos and people constantly submit pull requests and stuff like that. Like I don't even look into notifications anymore, honestly. They're absolutely cluttered and they became useless for me. So I really apologize that if you submitted something, I may not look into that for month and month. But sometimes from time to time, I look into them. Right. So, and by the way, if I don't look into your pull request for too long, and for example, I submitted something that breaks your pull request, don't try to close your pull request or try to fix or anything like that, right? If your pull request is valuable and good, I actually gonna backport it to the current version of Visualize or any project actually. So don't worry about that. So when you contribute something, you contribute not only the code, you contribute also an idea, right? And if the idea valuable enough, I also, but I couldn't apply your patch, I would backport it and also mark you as a co-author, right? So that's what I like to do. Anyways, so what was that? Yeah, so here it is, unlock FPS during video rendering. So let's take a look at that. So yeah, as you can see, it conflicts with the current code, but that's fine. That's not that much code. That is not that much code. We can do something about that. Ooh, they even suggested to add a new feature flag, the desired to render FPS of the application. I don't think it's a good idea to make it a feature flag, but then whatever. So this is a set target FPS. Oh, I see why they did that. So it's sort of like a global constant to which we can switch back to. Makes sense, makes sense. Oh, they also factored out okay, so that's actually kind of cool. Right, maybe I should accept that. All right, so start, finish, where is the, yeah. Okay, let's go ahead and just port that idea. Plug C, start rendering the track. So set target FPS to 0. Right, so let's find the places. Set target FPS to 60. And actually, there's 3 places now. Set target FPS to 60, and another one. Set target FPS to 60. I think that's it. So there's only there's 3 places. All right. Now let's try to recompile the whole thing. Yeah. I need to go back. Snob. All right. All right. So let's see if unbounding all of that stuff actually speeds it up. Okay. Honestly, I don't know. Maybe it does. We need to take a look at the playback. To be fair, it kind of feels slower. That is bizarre, honestly. It's just it's not that different. It's actually not that different. I have an idea. It's 2x? It doesn't say that it's 2x, actually. No, it's not 2x. Let's cancel it. Can you cancel it? let me do the following. Did I rebuild it? I think I did rebuild it. Let's stash whatever we have. Let's stash whatever we have, and I'm gonna rebuild it one more time. Let's go before our changes. Let's go before our changes, and I'm gonna try to render it now. No, it's kind of similar actually. All right, so it was that slow before. All right. So it's probably slow because I'm streaming. So I will have to check how that works after the stream without OBS and stuff like that. All right, so that's good. That's good to know. Okay. So let's put it like this. And now what I want you to do, I want you to all support the OGG format and see how quickly we can get to rendering Pilot Red Sun. So Paul, music, because the last time at the beginning of the stream we couldn't even start rendering, right? So because it basically froze the application and it just like was doing nothing, right? Because it was loading 45 minutes of the music into the memory. But now if we did everything correctly, it will not do that, right? So this is basically the final testimony of our approach. So right now OGG is disabled, so let's go ahead and enable it. Both look the same to me, same, right? So I suppose it's just because I'm streaming. Okay, so let me see. So what do we have in here? So we're doing Vorbis, and we have to provide the context. The question is, so it does the short thing. So that means the size of this sample is 16 bits. Right, so that means we have to allocate shorts in here. Let's go ahead and allocate some shorts. So we just provide the context as usual. Then we provide the channels. Okay, that's fine. And then we provide the samples that we allocated. So here we're trying to read some stuff. We can just say that we're trying to read num floats. And this is the amount of channels. We don't need any of that stuff. And we just return frame count. I think that's it actually. Surprisingly. I think that is it. We probably also need to do the conversion. Yeah, that's right. We need to do the conversion afterwards because it's 16 bits. That's pretty cool. So now if I try to compile this entire thing, it should be compilable. It's still not compilable because STB Vorbis, we don't have STB Vorbis in here. Let's do STB Vorbis, but C. All right. Okay, so this is sample C, a little bit of a typo, that's fine. A little bit of a typo. Oof, what the fuck is this? Get for STD Vorbis, multiple definitions of STB. So, since STB Vorbis is like C, it's not a header only, it doesn't allow you to just include the declarations. That fucking sucks. That fucking sucks. This is nuts. What we're gonna do about that? Right, so because we just included this thing, but it also, yeah, that's ugly. This is why, by the way, this is literally why single header libraries also like have this implementation macro. Right, so because you can decide whether it includes implementations or not. So because now we have two implementations for the same function. And I suppose STB Vorbis was implemented before Sean Barrett figured that out. So that's probably what happened in here. But maybe it has some sort of a macro that just allows you to do that. Like I don't see implementation. Yeah, so there's no implementation macro. Why was it turned into a C file? Do we know? Yeah, I think it's a very old library that, like, because as far as I know, somewhere Sean actually said that he didn't figure that out immediately, that you need this implementation macro, right? So he kind of like learned that the hard way. So, and I guess that's basically the way he learned about it. Okay. So let me see if maybe it has something for the, maybe it has a version of that declare. Nah, probably not. I suppose what we have to do, we have to just like have our own declarations, right? So just have our own declarations. Let me actually see. We don't even really need this kind of things, honestly. Do we really need that? But maybe not. Anyway, so stb, let me find this function and find, yeah, I can just put it like that. And don't include stb verbis. It will complain about the lack of the declaration of the structure, but maybe that's fine. Yeah, okay. So it doesn't know about stb verbis. I have an idea. What if I say that type def, you know, struct stb verbis, So I'm gonna say it's opaque because I don't really care about its internals, honestly. That was easier than expected. Okay, so it's just like forward declare it yourself. That's cool. That's cool. All right, so let's actually see if it's going to work now. We need to, let's try to use the OGG version, that is small one, right? So, and let's just render it. It crashed. It fucking crashed, mate. For fuck's sake. Get fucking damn. Okay, so I wonder why it crashed. So it started actually really well, I think. Alright, so but then it crashed, so I probably fucked up something. But that is fine. So frame count red. So this is the amount of frames, and yeah, I guess that's fine. So this is the amount of samples. Yeah, I think I know. I think I need to do this stuff. Oh, I see. First of all, I need to do that, num samples, right? And also I have to get rid of the while true. Right. To be fair, num samples is kind of like a very common thing, so I probably just need to do it once in here and just like use it throughout. So this is the amount of channels, this is samples. Channels, samples, num float. And stb verbis. I need to go in here just when I read. So it's a num shorts. All right. I don't think I need to do it like that. So this is the amount of samples I allocated. It's a bit confusing, right? So because the doctor wave expects you to provide the amount of samples, but this one expects you to provide the amount of, yeah. So this is a num, but it's not sample, it's frames. Get fucking damn it. Okay. It's frames. I should have not called it frame. Yeah, fuck. I suppose I'm just gonna do it like that. And I probably need to clean that up after the stream, right? Because it's a very tricky and very easy to mess. It's very easy to mess. Let me just have it nearby. So this is a num floats. So just provide the buffer. So that's pretty cool. But then it returns the amount of frames that is read, and because of that, it's totally fine. Okay, I think that's basically what I have to do. Right, that's basically what I have to do. All right, so let me see. Depending on different libs is a bit yeah, it is true, especially in the domain of audio, where the terminology is also kind of confusing. Like people sometimes mean different things by samples, frames, and stuff like that. And it is extra annoying, I think. And okay, I fixed it. A little bit of a pondering upon the code actually helped. So just like meditate a little bit and it works now. So I just want to render it out and confirm that it works, right? It works as expected. And afterwards, we're going to try to render the, 45 minutes one. So as you can see, it's lagging a bit. Is it visible that it's lagging? Like at least on OBS preview, it is lagging right now. So how everyone is doing? Tell me chat, how are you doing, meine Freunde? No lag for me? Okay, so that means my preview is lagging slightly. So where to see daylight outside? I know. So I'm a night creature. Doing well. I'm really glad to hear that. I'm gonna bake soon. What you gonna bake? Bread? You graduated university. Congrats. Congrats. Yeah, some people say samples instead of frames. An idea of multiple samples per slice is oh my god. Yeah, so everyone is just confusing everything. Since sinus headache going well. Oh my god, that's the worst. That's the worst. I hope you get well. Synonym rules. My game released went surprisingly well for zero market. Nice. Like I saw the screenshots of the game, so they look actually kind of cool. So I couldn't play the game because I cannot pay for it. But it looks interesting. Looks interesting actually, and the fact that it's implemented in Jai, right? So the fact that it's implemented in Jai is actually kind of cool. So you basically use the ARM compiler, right, to implement it for Android. So I suppose, yeah. So the ARM compiler is already out. Maybe, I don't know. I haven't checked it for quite some time. You can post the link in here, right? So posting links is not forbidden, at least anymore. ARM compiler ready. Nice. All right, so it's almost done. Come on, you can do that. I believe in you. All right. So let me see if it actually did the thing. Right. That worked fine. Now, here's the moment of truth. We wanna get the pilot Red Sun and see if it will at least start rendering. Right. So we're probably not gonna wait until it's finished rendering completely, but let's see if it will at least start rendering it right away. It did. It is actually like started actually rendering it, and according to the law, it is rendering it. Look at it go. Yeah. So before it was impossible to even start rendering this thing because it was stalling on trying to load the entire song into the memory. Now it doesn't even have to. It doesn't even have to do that. We don't really support all of the formats, but it's pretty trivial to actually go through each individual supported format and just add support for that. And this is something that I'm gonna do already off screen, right? So I just like outlined the feature, I researched what needs to be done, and I figured it out, right? So we just need to implement this kind of thing in here. So I don't know if it is possible to contribute this kind of stuff to Raylib. I don't really think so. One thing maybe I would suggest to contribute to Raylib is making this thing public, so people then can like at least reliably switch keys on these things, but I don't really know, right? So maybe I'll try to submit a pull request and ask Raysan what he thinks about that. But yeah, so that was a pretty productive stream. I didn't expect that it will get something actually working and fixing an actual problem today, right? Because this was an actual problem, right? So you couldn't render big files. You couldn't do that. Now you can, because we just like reuse the same like opened context that Raylib already opened for these libraries. So yeah, that's pretty cool. That's pretty epic, I think. So anyway, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Zozin. Off screen, I'm gonna add support for the rest of the things, and I will see what kind of things I can get back to Ray-san, what kind of feedback. Right, so thank you everyone for watching. Love you. Mwah.